Hello everyone, welcome to physics class. Today we'll start new chapter 11, work and energy, and this is last chapter of your physics syllabus. First, outline of this chapter. This is what we are going to study in this chapter. We'll start with work. What is work scientifically? Then concept of energy, definition and different forms of energy that we are going to see. And in that different form, particularly we're going to talk about kinetic energy and potential energy. Then power, then commercial unit of energy. That is how to generate electricity bill that you obtain in your house every month or every second month. Let's start with work. Now when you're saying you're working hard for your exams, or when you're working hard to understand anything, scientifically all these things means you have done zero work. Yes, working hard. This work has different definition in different contexts. Here it is different. Scientifically, work means when you're applying force to any object. Or let's start this with an example. Let's say you have one object standing on a flat surface. It is horizontally kept over here. Now I am applying some force on this object like this. Now this object is displacing from its position that you can see. So it is here and I am applying force in this direction. So when I am applying force, it is displacing from its position. Right? Position is changed. This object position is changed. Here I have done work. Scientifically, here I have done work because this object, it is now not at the same place. By applying force, I am displacing this object. So by this simple example, you can write definition of work, which is nothing but applied force and displacement of this object. So definition of work scientifically is work is equal to force, applied force multiplied by displacement of that particular object. Displacement and distance, they are two different things. As we have studied in chapter 8, displacement is vector quantity and it is the shortest distance covered. It is the distance between initial position and final position. So what is work done in this case? Let's say if I am applying 10 Newton force in this direction and object is also displacing in same direction. Okay, I am applying force in this direction, object is also displacing in same direction. So when I apply force, let's say I am applying 10 Newton force and displacement of this object is 1 meter. Then in that case, my work done is 10 Newton meter. Okay, so example, let's say I am applying 10 Newton force and 1 meter is displacement and both of them are in same direction. So in this case, my work done is 10 Newton meter. So the standard unit of work is Newton meter, or you can write Newton meter as joule. Okay, so SI unit of work is joule, or you can write this as Newton meter. So you can define 1 joule as when you apply force of 1 Newton and the object displaces by 1 meter, then work done on that object is 1 joule. Okay, now as you know, force and displacement both are vector quantities. Now work done can be negative or positive depending on direction of, because you have only two quantities here, force and displacement. So depending on direction of these two, you can define work done as positive or negative. Okay, now when you are applying force and if the direction of force and displacement is same, in that case your work done is positive. So what I can write is, so your work done is positive, or I can write work done. It can be positive or it can be negative. Okay. When it is going to be positive? When direction of force and displacement are same. That means they both are in same direction. Simple example, when I am pushing something, let's say when I push kick a ball or I push a heavy table, so I am applying force in this direction, the object is also moving in same direction. In that case, work done is positive. Now work done when it can be negative. It can be negative when force and displacement direction are opposite to each other. So negative when force and displacement direction are opposite to each other. Okay. Now, can you think of any example when you apply force and displacement is in the opposite direction? Yes, a common example is, let's say this object, consider this as your ground. Let's consider this my palm as ground. Now, you know this object is here on the ground because of gravitational force. Now, when I lift this object, gravitational force direction is downward direction. When I lift this object, the displacement direction is upward. So, in this case, when I am lifting object, work done is negative. Then I am considering gravitational force and displacement. But in the same case, if I consider muscular force is also in this direction, displacement also in this direction. So, if I talk about muscular force and displacement, work done is positive. But in the same case, work done by gravitational force on this object is negative. Because gravitational force is in downward direction, whereas when I am lifting this object, the displacement is in upward direction. So, example of this is when you lift any object against gravitational force. So, this you have to specify when you lift any object against gravitational force. Because simply lifting an object can be positive work, because if you consider this as work done by your muscular force. So, you have to write example over here, and this is simply pushing an object. So, if you push an object in each direction, it is displacing in each, that means your work done is positive, negative, lifting the object against gravitational force. Now, there can be third thing for this work done. Okay, so work done can be positive, negative, it can be zero also. Okay, work done can be zero also. Now, think about this, how, on which condition work done can be zero. In the next class, we'll talk about this important thing. Okay, so after seeing this video, think about this condition also, and then we'll talk about it in the next class. Thank you.